एही कार्यक्रमर सह प्रायोजक हेले
Good afternoon, my dear students. Once again, Hiranmai is here to take your physics class in online class today. So, yesterday we had discussed about the dimension, how to derive the dimensional formula and its uses, right? Also, I had given some homework for you. Hope you all have solved for this. So, let us go for the uses of dimensional analysis, and I had also explained the first dimensional analysis. There are actually three uses of dimensional analysis. What are they? First one is the conversion of units. That means to convert one system of unit to another system of unit. The second one is to check the correctness of a given physical relation or physical equation. Suppose an equation has been given to you, and dimensionally you have to check whether this equation is correct or not. And the third use is to derive, to establish the relationship among different physical quantities. Okay. So, the first part I had just explained you, just given the formula, derived the formula. So, let us have a recap or quick recap on that, so that you can go further. Okay. So, the first, the conversion of units. Okay. This is the first application or first use. As I had told you that suppose this is 1 meter, I say 1 meter, you say or somebody says this is 100 centimeter. That means this is what? This is the quantity called length. So, the length does not change. So, the physical quantity does not change. What is changing? The represent, how you are representing the system of unit, the unit, the system of unit which is adopted, accordingly it is changing, but the quantity remains the same. So, if I represent this quantity, I gave you the example of length. So many quantities are there. So, to generalize a formula, let us take the physical quantity as Q. Clear? I had explained this yesterday, but as I will solve some numericals on this, so let us revise it. So, Q, which is always, any physical quantity always represented in terms of its numerical value along with its unit, that I had told you, like 1 meter, 100 centimeter. This is the unit, this is the numerical value, this is the length, correct? So, any physical quantity remains the same. So, suppose I take the physical quantity Q and expressed it in two different system of units, then if U1 is the first system of unit, then say it is N1 U1 like 1 meter, and another one is N2 U2 like 100 centimeter. So, N2, suppose this is known to you, this is unknown to you. You are interested to calculate this. So, N2 will be written as N1 U1 upon U2. Now, U1 is one system, U2 is the another system of unit. So, whatever the system of unit is, for example, as I told you, the length is the physical quantity, or say speed. Speed, the dimension of speed is LT minus 1. So, speed, whether it is in meter per second or kilometer per hour, the dimension remains the same. It is 1 minus 1. So, whatever but the system of unit is, dimension remains the same. So, it is N1. Suppose in U1 or the first system of unit, the physical quantity is expressed as M1 L1 T1, whereas its powers are A, B, C, like in case of speed, for example, and its and In U2, it's M2 raised to A, obviously, because 1 minus 1 will not change. The physical, as we have taken the same physical quantity, so the exponents will not change. T2 C. So when we generalize the formula, N2 is equal to N1, M1 upon M2 raised to A, L1 upon L2 raised to B, T1 upon T2 raised to C. So this is the formula. Up to this we had derived. Now I had also told you, I had asked for you, you have to convert using this formula 36 kilometer per hour, how much meter per second? Did you solve? Hope you all have solved, or if not, don't worry, I am doing it how you are using this formula to solve this, okay? See, 36 kilometer per hour. All of you note it down so that you can understand better in future when you refer it. Meter per second. Suppose this is, that means this is N1, this is N2. Okay, so this much is to be calculated. So N or N2, say N1, it's M1 upon M2, A, L1 upon L2, B, T1 upon T2. See, here N1 is 36. M1 in mass, it is kilometer per hour. There is no mass. So M1 upon M2 raised to 0. So it's 1. So there is no need to write this, as the mass quantity is not there. Then length. In first system of unit it is kilometer. So 36 multiplied with kilometer, and here it is in second system, it is in meter, raised to kilometer per hour or meter per second. What is the dimension? This is the unit of speed. Its dimension is LT minus 1, L raised to 1. So this is the value of B is equal to 1. This is the value of C, which is equal to minus 1. So it's 1. T1 is what? It's hour upon, this is second, raised to minus 1. So 36, 1 kilometer, it's 1000 meter upon meter raised to, it's just mathematical calculation. 1 hour is how much? 3600 second upon second minus 1. So meter gets cancelled, second gets cancelled. So finally you will get the answer how much? 36 multiplied with 10 raised to 10 to the power 3 into, here it's 3600 to the power minus 1. So I can write it as 36 into 10 to the power 2. So this gets cancelled. Now this gets cancelled. So rest remain 10. So finally we got the value, it's 10 meter per second. Let's take the call. Hello? 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 TV volume कम करके क्वेश्चन पचारंतु वॉइस क्लियर होनी. हेलो हेलो
Ma'am,
हाँ एबे सुना गला.
ma'am, can you explain again N and mu?
सॉरी
Now, can you again explain N and mu?
N and U. Sorry, N and U.
N and mu.
N and U, the notation I have given, right?
And mu. Yes, ma'am.
N and U, I have given the notation,
Yes, ma'am.
right?
Yes, ma'am.
Okay. N is what? The numerical value. I told you. Okay. First be very clear how a physical quantity is represented. In the very beginning I told you 1 meter. I said it's 1 meter. You said it's 100 centimeter. Suppose this is 1 meter, this much. Okay, you just observe it carefully. This is 1 meter, but this is 1 meter as I said. You said it is 100 centimeter, but this is the length. And when you are saying 100 centimeter, is it increasing? No. When I am saying it's 1 meter, is it decreasing? No. Length is remaining same. So the length is what? It is a fundamental physical quantity. Yes, obviously it is a fundamental quantity. It is a quantity. So quantity remains the same. Only there is a change in the value of the numerical value, the number. When I am saying it 1 meter means in 1 unit. SI unit, suppose I am saying it in meter and you are saying it CGS unit in centimeter, then it is becoming 100, and when I am saying it 1 meter, it is becoming 1. So 1 is its numerical value, meter is its unit. So unit is U and N is its numerical value. Clear? So any quantity is represented as, where any quantity Q is represented. Suppose I take quantity as Q, physical quantity as Q, then Q is equal to its numerical value N. So N is the numerical value multiplied with its unit. Clear? Hope you have cleared. So finally we got the answer. Next I think you have studied in 10th 1 Newton force. This is the unit of force. 1 Newton is how much dyne? 1 Newton is how much dyne? Hello? Let's take a call. Doubt Kaharaj. Hello? 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 Hello?
Ma'am, I want to ask a question.
Yeah, sure.
You explained that 36 km per hour is equal to 10 meter per second, but how you calculated the B and C value?
B and C value, I mentioned na, kilometer per hour. Tell me, kilometer per hour or meter per second is the unit of which quantity? Speed. So when it is the unit of speed, then I have already mentioned or already derived the dimensional formula for speed. So what is the dimensional formula for speed? It's distance upon time or displacement upon time, velocity. Yes or no? So as it is in kilometer per hour or in meter per second, it's what? Kilometer or meter is what? It is distance. Hour or second, it is what? It is time. So distance upon time. So LT minus 1. So here L1 T minus 1, that means M0 L1 T minus 1. A value is 0 here, B value is 1, C value is minus 1. Clear? Okay. Then let's solve for 1 Newton is equal to how much dyne. Then I will give you a homework for you today. 1 Newton is how much dyne? First tell me, what is the unit? Newton is the unit of which quantity? It's force. So let's calculate for the dimension of force that already you know. It's MLT M into A. Already we have derived. How it is derived? M into A. So it's MLT minus 2. That means A is 1, B is 1, C is minus 2. So suppose this one is N1, how much is N2? So N2 is equal to N1, M1 upon M2 raised to A, L1 upon L2 raised to B, T1 upon T2 raised to C. N1 is how much? It's 1. Mass is how much? Newton. Kg meter per second square. So it's in kg. Yes or no? Then Newton is the SI unit. Clear? Newton is the SI unit. Dyne is the CGS unit of force. So it's in kg, and M2, that means in CGS unit, it's gram raised to how much? A is 1, L1. L1 is how much? It's kg meter. So it's meter, centimeter raised to 1. Second, same as it is, raised to minus 2. So 1, no need to write it. 1 kg is how much? 1000 gram upon gram raised to 1. 1 meter is 100 centimeter. Second, let me write. Now this gets cancelled, centimeter gets cancelled, gram gets cancelled. So how much is left? It's 1100. So it's how much? 10 to the power 3, 10 to the power 2. So it's 10 to the power 5. So you have already studied in your lower classes, in your 10th class, 1 Newton is 10 to the power 5 dyne. All of you noted down? Now, next homework for you. You just calculate 1 joule is how much erg? Joule, erg. Joule is the unit of energy. This is the SI unit of energy. This is the CGS unit of energy. Okay? And already I have told you in the yesterday's class, what is the dimension of energy? It is same as that of work. What is that? ml2 T minus 2. So A value is 1, B2, C minus 2. Clear? So it's a homework for you. Next. What is the next application? It is to check the correctness of a given physical equation. Let's see. To check the correctness of a given physical equation or relation. That means dimensionally you have to check whether this given equation is correct, dimensionally correct or not. How do you know? In order to explain or in order to prove or in order to check it, you should know a principle. Okay? Using that principle only, you will be able to check whether it is dimensionally correct or not. What is that principle? That principle is called, hello? Hello? Hello?
Hello.
हाँ टीवी वॉल्यूम टिके कमे देखी लाउड रे कुह लाउड वॉइस रे
Good afternoon.
वेरी गुड आफ्टरनून
Hello.
हाँ ଶୁଣୁଛି ମୁଁ ଶୁଣୁଛି କୁହନ୍ତୁ କ୍ୱେଶ୍ଚନ କଣ ତୁମର okay so to check the correctness of a given physical relation in order to know this we should know a principle. So that principle is called principle of homogeneity. Okay. Principle of homogeneity. Homo means what? Same or equal. What's the principle says? Or how we use this principle to check the given physical equation is correct dimensionally. So according to this principle, the given physical relation or physical equation is dimensionally correct if each term of the given equation in both sides, each term of both the sides of the given equation have same dimensions. I repeat, According to this principle, if each term of a given physical equation, if each term on the both sides of a physical equation have same dimension, then we can say that the given physical equation is dimensionally correct. For example, you must have studied about the equation of motions, 3 equations of motion we have studied now. Let us take one. S is equal to u plus half at square. How many terms are there? This is one term, sorry, ut. S is equal to ut plus half at square. So, this is one term, this is one term. Okay. Remember one thing, that the what is the meaning of this principle of homogeneity? According to this principle, that the dimension of each term on both sides of the physical equation remains same. That means what? This means that we can understand that velocity can be added with velocity. Velocity cannot be added with force or any other physical quantity. That means physical quantity of same kind are added or subtracted or compared. Okay, like length added to length, velocity added to velocity, force added to force. Clear? So, this is one term, this is one term, this is one term. Okay. So, you have to find the dimension of each, dimension of S, dimension of ut, dimension of at square. Half, as it is the numerical value, it has no dimension. So, you have to take the dimension, find the dimension of at square. What is u? U is the velocity, t is the time, a is the acceleration, t is the time. Okay. So, you solve for it. We will come after a very short break. Welcome back. I had given you a work to find the dimension of each term, right? Hope you all have tried or you are trying. Let me try. Dimension of S is what? It is distance, so I can write it as L. Dimension of this term ut, u is what? I told you it's velocity. So, you have to remember while doing again and again, you will remember. Okay. So, it's LT minus 1 T. So, it's L as T minus 1 into T. So, it's T gets cancelled, T minus 1 T gets cancelled. So, simply it's L. Then at square, acceleration. So, what is the acceleration? It's LT minus 2 and t square means t. So, minus 2 gets cancelled. So, simply L. Now, see, LHS one term was there, RHS 2 terms were there. Both sides, each term, dimension of each term is equal, L, L, L. So, now we can say that yes, this given physical equation is dimensionally correct. You have studied about another equation of motion, V is equal to U plus AT. This is a homework for you. Try for it. Also, another equation already you have studied in your V square minus U square is equal to 2AS. V is velocity, U is also velocity, A is acceleration, T is time. Again, V is velocity, U is velocity, acceleration, S is distance. Ignore 2 as 2 is a constant, it has no dimension. It is a dimensionless constant. Clear? So, hope all of you are clear about this. Next, I will give you few more examples like Fs is equal to half m v square minus half m u square. Can you do it? Yes. Force Fs, you have to find the dimension of each term. The dimension of force mLT minus 2 S means L, sorry, I am so sorry, L, so it's M L 2 T minus 2 mv square. V is velocity, m is mass, so velocity is LT minus 1 square, so it's m L2 T minus 2. Clear? Then m u square, the same way, m same way like this, okay, m L2 T minus 2 will come. So finally the dimension of each term remains the same. So the given physical equation is dimensionally correct. Now I will give you another example. Lambda is equal to h upon mv, where lambda is the wavelength. आप लोग तमे मते पचारिबो सब एबे लैम्बडा टा कोन पढिबो जतेले डिटेल्स waves optics तक जानिबो. It is just a length. Now you have to understand it is the length. H is a Planck's constant. It is a constant like we have studied as gravitational constant. It is also another constant which is called Planck's constant. M is mass, V is velocity. Okay. Now you don't know the value of H, right? I have not told you. See the formula, how you can calculate the dimension of H. The formula energy E is equal to H nu, or H is equal to U E upon nu. This is Planck's constant. Note it down, be careful. Otherwise you cannot solve this. H is equal to E upon nu. From this relation you can get the dimension of H. So H is the Planck's constant, E is energy. I am not going to solve it, you have to solve. I am just explaining how are you going to solve it, okay. And this is frequency. Frequency again you will study it in later chapter, but basic idea you must have. Frequency is equal to 1 upon time period, or 1 by time. So use these formula and check whether this relation or this equation is dimensionally correct or not, okay. Now come to, okay, hello, 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 hello,
हेलो
हाँ
मैडम नमस्कार.
नमस्कार
मैडम नमस्कार.
नमस्कार कुह क्वेश्चन कौन कुह.
हेलो
हाँ मु सुनी पारुची क्वेश्चन कौन कुह तमरा क्वेश्चन कौन.
मैडम कुश्ती
टीवी वॉल्यूम म्यूट करो ताले जाई कि तमे मो कथा सुनी परिबो मु तमो कथा सुनी परिबी. Okay. Now next only one other type of equation I will take, then we will come to the next application, okay. Y is equal to A sin omega t minus kx. Suppose this type of equation is given, how, and question is been given, you have to find the dimension for this omega and dimension for this k. What is the dimension of this and what is the dimension of this? This question has been given to you. How can you calculate? So this is sine of this, that means this is an angle, this is an angle, this is also an angle. Physical quantity of same kind added, subtracted or compared. That means if this is angle and it is given, one more thing, it is given t is equal to time, x is equal to distance. Clear? Now, so you have to find, as sine means is a trigonometric function, so sine of this means sine is angle, so this is an angle, kx is also an angle. That means omega t dimension will be what? What is the dimension of angle? Yesterday I had told you it is dimensionless. Yes or no? It's arc upon length. So you can write it as 1. So you have been asked to find the dimension of omega. It's 1 upon t. So it's t minus 1. Clear? Again, kx. It is all again its dimension is equal to the dimension of angle and it is equal to 1. So dimension of k will be equal to 1 upon x. What is x? It is given distance. So it's L minus 1. Clear? Now this much for you for the second use. Then we will come to the third part. This will take time to understand. If I will solve 2 to 3 problems, then you can have some idea. Okay? The more you solve numericals, the more you solve the problems, the more concept you will be cleared. Okay? So next come to the third one. What is that? To derive the relationship among different physical quantities. To derive the relationship among different physical quantities. Clear? How? तुमको बहुत सारा क्वांटिटीज फिजिकल क्वांटिटीज दे दिया हेची आ तुमको बाहर करिवार अछि और एस्टैब्लिश करिवार अछि सेमानक भितरे गोटे फिजिकल इक्वेशन और फिजिकल रिलेशन किमिति करिवो हाउ बाय यूजिंग द प्रिंसिपल ऑफ होमोजेनिटी बट कंडीशन इज दैट you should know on what factors these physical quantity depends. So to derive the relationship among different physical quantities, how to derive? I told you by using the principle of homogeneity, but if we know on what factors these depends. Okay, let's take an example, then you will understand a little. We'll solve 2 to 3 numericals. Suppose तमे समस्ते एमती चाबी रिंग एमती घुमाओ. अच्छा यू जो माने समस्ते भी देखुच मते तमे समस्ते निजे निजे ट्राई करो एमिति जेते बेले घुमौच यू आर फीलिंग एन इनवर्ड फोर्स. तमे गोटे भीतर आड़ को गोटे फोर्स पकोच ताहले जे कि चाबीटा बुलुची. यस और नो? So whenever a body moves in a circular motion, a force is required. That force is called centripetal force. Okay, that again you will study in details in your later chapters. Circular motion जेतबेले पढ़िबो details सेतबेले. So this is, suppose F is the centripetal force. The centripetal force, suppose the question is like this: the centripetal force F depends on, or the centripetal force required, how much is the, you have to establish the expression or you have to find the expression for centripetal force, and we know that the centripetal force F depends on the body of mass m which is moving in a circular path with velocity v. That circular path the radius is r. Okay, we have to find the expression for the centripetal force of a body of mass m moving with velocity v in a circular path of radius r. That means what? We came to know that this centripetal force depends on how many factors? Mass of the body, velocity of the body with which it is moving, and the third one is the radius of that circular path in which it is moving. So, but we do not know how it depends. So, let us assume that it depends directly like this. Let us assume that this centripetal force depends on the mass of the body m, but how we do not know. It also may not depend, here it depends obviously, but in some cases it may not depend. How you will come to know? After getting the value of the power, let us m to the power a, suppose a value will come to 0, then it does not depend on mass. But here let us see it depends or not, finally we will come to know. So, but we came, as in question it is given that it depends on mass of the body and velocity of the body with which it is moving and the radius of the circular path on which it is moving. So, mass raised to a, radius of the body b, and velocity of the body raised to c. How they depends we do not know. So, combiningly we can write f is proportional to m to the power a, v to the, does not matter, r to the power b, v to the power c, or we can write it as, note it down all of you, f is equal to, when the proportionality is, I will replace it by equality, equal sign, then I will put a constant, proportionality constant, which is dimensionless. So, I will write m raised to a, r raised to b, v raised to c. Let it be equation 1. Okay. Now, you have to, up to this I hope you all have noted down. Let me rub slowly, do not worry, I am going very slowly so that you can note down all the things. F is equal to k m, this equation finally you have got. Now, by use, how you will use principle of homogeneity? You have to equate the dimensions on both sides. So, what is the dimension of force? It is m L T minus 2. Yes or no? What is the dimension of mass? It is m. What is the dimension of, what is the dimension of what is the dimension of, let me divide it so that, so what is the dimension of r? It's L, V, it's L T minus 1. Clear? Now, just use this in both the sides of the equation. So, dimension you have to use, dimension of k is dimensionless. So, f, it's m L T minus 2 is equal to mass. What is the dimension of mass? It's m. What is there? Power is a. Listen carefully and watch carefully so that you can understand. R raised to b, R, it's L raised to b, velocity v, dimension is L, T minus 1 raised to c. Now, just solve it mathematically. How? M raised to a, it will be m a. L raised to b, L b, L t minus 1 raised to c. So, L c t minus c. Yes or no? So, now, finally, you just in MLT form you have to write. I am writing it here, m raised to a, l raised to here, l raised to b, l raised to c. So x to the power m into x to the power n. What will be written? X to the power m plus n. The same way, l to the power b plus c, then it's t raised to minus c. Clear? In left hand side, it's mlt minus 2, 1, 1, minus 2. Now just see this equation. mlt, mlt, both sides the base are same. When the bases are same, the exponents will be equal. So you can equate the exponents, the powers. So for m, base is same, so a is equal to 1. For L, equating the exponents, b plus c is equal to 1. Then t raised to minus c, here minus 2, minus c is equal to minus 2. So c is equal to 2. C is equal to 2. Here a is equal to 1. Clear? So here c is equal to 2. So what is the value of b? From this equation we can get. So c is equal to 1 minus b. So it's 1. Sorry, I am so sorry. Here we have to calculate b, na? So 1 minus c. So it's 1 minus c is 2. So b is minus 1. Okay. So finally you got the value of a, b, c as 1, minus 1 and 2. So now put these values in this equation. Simple. Let's see. Now putting all these values in equation, f is equal to k m to the power a is 1, r to the power b is minus 1, v to the power c is 2. So I can write it as m v square upon r. So finally I got the expression for centripetal force is how much? Kmv square by r. Okay. So hope all of you are clear. Now next come to one more problem, one more numerical. So that you can have some idea. Okay. So it is given the frequency of a vibration of a straight string depends upon frequency of vibration. Frequency is given as nu. A straight string is there. Straight string means it is fixed at both the ends. When we pluck it, then it will vibrate. Okay. So that frequency of vibration of that straight string depends on first. किसके ऊपर डिपेंड करता है? Depends on its length L. Its length L. Its length L. Then its mass per unit length. Yes, here mass per unit length. M. It has given, the notation has been given. Mass per unit length. Already we have solved this type of dimensions we have calculated yesterday class. Also I have given some homework for you. And the third one, hope you have done it. It's the tension in the string. Tension is nothing but the force, okay? The tension in the string T. So this frequency depends on these three things. Now you have to find the relation between or establish the relation between, see how many quantities, physical quantities are there? 1, 2, 3 and 4. You do not know how they are related to each other. So first do it. How we have done in the previous numerical? nu, let it is proportional to L to the power A. Also depends on mass per unit length to the power B. Also depends on tension in the string to the power C. So, its nu is equal to, directly I am writing K L to the power A, M to the power B, T to the power C. This is the equation. Now, what is your work now? You have to find the value for A, B, C. Put the values of A, B, C here, then you will find the answer. Let's do it. Then I will give you homework. Yes, this is the equation. Okay. So, just now, few minutes back, I have told you the dimension of frequency. What is that? It's 1 upon time period, or it's -1, t minus 1. Length, dimension of L, it's L. M, what is M given? This is important. M is not mass given, it's mass per unit length. Mass upon length. So, its dimension will be not M, rather it's M L raised to -1. Clear? So, mass per unit length means mass upon length. So, its dimension is ml minus 1. Then T, tension in the string, its force mlt minus 2. Now, just equate it. Do it. T minus 1 is equal to, dimension of K is 1. So, L, length, L raised to A, M, dimension of M is M, L minus 1 raised to B. Then T, dimension of tension is MLT minus 2 C. Clear? So, you just solve it. L raised to A, M raised to B, L raised to minus B. Then M raised to C, L raised to C, T raised to minus 2C. Clear? So, just set it in a sequence. So, M, first M, so B plus C, then L, A minus B plus C, A minus B plus C, then T minus 2C. So, equate it. So, T minus 1 means what? It's M0, L0, T minus 1, which is equal to this much. Yes or no? Which is equal to this much. So, B plus C equal to 0, this much equal to 0. So, let's solve it quickly. B plus C is equal to 0, A minus B plus C is equal to 0, and minus 2C is equal to minus 1. So, C is equal to half. C is equal to half, we got it. So, B is equal to minus C, minus half, and A will be equal to B minus C. So, B is what? From this, B minus C. B is how much? Minus half, minus C is half. So, minus half will be 1. Minus half, which is equal to, A is equal to 1. Yes or no? So, we got the value of ABC. Now, put it. Therefore, frequency is equal to K L to the power 1, M to the power B is minus half, C to the power half. C to the power half means its square root. So, K L, it's 1 upon root over of M and root over of C. Sorry, I am so sorry, T to the power C. So t to the power half. So t. So finally, what is the final equation? Nu is equal to k L root over of t upon m. Clear? Next. एक second. L, the value of L is this, it should not come, it should be k by L, L should be -1. Let me check A value. Oh sorry, -half, it's -1. I am so sorry, note it down, -half, it's -1. So A value is -1. So it will be L to the power -1 means 1 by L. I am so sorry my dear students. So just check it, k by L root over of t by m. Clear? So this is correct. So now, so sorry I cannot give you homework. Try for yourself referring other notebooks. Thank you, best of luck.
ଏହି କାର୍ଯ୍ୟକ୍ରମର ସହ ପ୍ରାୟୋଜକ ହେଲେ